Here we have an image of the Earth as shown by the International Space Station High Definition Earth Viewing Experiment. There are, if I understand correctly, 4 different cameras. I think it's 4 that this switches between. And I don't know it. Oh, I was going to say I don't know at what point in time it's going to switch cameras, but apparently it's doing that right now. I'm thinking. We just went to a blackness, and yeah, there. Please stand by. So I'm going to switch to another tab for now. In this tab, I have iss.astroviewer.net, and I'm going to scroll up the page just so you can see what the top of the page looks like. As I scroll down the page, you'll see this map area, which shows basically what is being gone over by the International Space Station right now. This is not a real-time video, this particular one. It's just a map being scrolled in real time. And as you can see, looking at this map, which is not even an image, but rather a drawing of what the land looks like, but shows a very, very good representation of where the International Space Station is over. You can see its ocean below it. So when we go back up and look at this thing, that's what you're looking at is ocean. And those areas of what looks like small hills and valleys and such, I would think that has to do with how deep the ocean is in that area. Not really sure, and I'm not exactly sure how that particular image was made either, but it's kind of like looking at Google Earth or something to that effect. As a matter of fact, I wouldn't be surprised if they're using the same image. Well, let's see. It says map image by NASA, so no, I'm thinking that's a different source. But let's see. It says this view. This is the view from the ISS directly down to Earth. The crosshair indicates the current ground point. In other words, the point on the ground, or ocean in this case, that the International Space Station is directly above. In other words, a place that if you were at, you could look straight up from and see the International Space Station, although you wouldn't see it real well because, it's about 250 to 260 miles up in the air. It says the map is updated every second. Please note that the map is not real-time video. However, the position itself is real-time. And then as I scroll down back to this other one, you can see the ground track, and the explanation under that. It says this map shows the ground track of the International Space Station's next orbit. So if you look at the little crosshairs in this case, you're just coming up on the twilight area. Now notice the ground directly beneath the space station will be going into nighttime very soon. But the space station itself will still stay in daylight until it hits the end of this red part of the line and reaches the blue area. So notice it's in daylight a lot more of the time than it's in nighttime itself. In other words, the space station is lit by the sun more than half the time that it's in orbit because of its distance off the ground. I'm going to go back and check this other page, and okay, we're back. We've got the image of the Earth back, and if you look very carefully, you can see the Earth rotating, and the direction of the rotation appears to be away from us. Or in other words, that the space station is moving in the direction of, if the screen was 3D, what would basically be out of the screen. And relative to that, of course, the Earth is rotating. The surface of the Earth is rotating what would be deeper into the screen. Again, if the screen were actually 3D. Now I notice we've got some artifacts going on there, and that's probably gonna get a lot worse as we continue. because of the fact that we're heading toward nighttime, and as you can see, the horizon is quite bright there. Eventually, and I'm not sure if the sun is going to be in the picture or if it's going to be off to one side of the picture, but the direction it's moving, I'm thinking the sun is going to end up probably pretty much right in the frame. And depending on how well this camera adjusts for such brightness, we'll get some degree of lens flaring and things like that. Of course, there's nobody out there putting a filter on the lens when that time comes, so it won't be filtered. And yeah, if the sun actually does get into the image, it will most likely be bright enough to pretty much blare over everything else. That all you'll have is one big glare on the screen. You might get some pretty colors or something, but for now, just kind of wait and see what happens. Now, if I don't know if you can see my mouse cursor or not. That with the software I'm using to film this, that seems to be a sort of inconsistent thing. But if I bring my mouse cursor here and point at a small piece of cloud, and if you can't see my mouse cursor, just pick one for yourself and maybe put your I was going to say put your finger on your screen or near your screen, but if you have to mark the position. But of course, if you have a touch screen, you might not want to do that because it could move things or take it as a click. But as you can see, if you can see my mouse cursor, if I mark a cloud with it, say this, oh, it went away. Well, I didn't have a chance to do that one. At any rate, what I was going to say is they were moving upward away from the mouse cursor. So again, I'm going to switch back over to this other screen here. I believe I accidentally closed it. Let's see. See if I can bring it back. There it is. And yeah, now you can see the space station actually should be over dark ground. Now that would be if you're looking straight down from the space station. And again, this upper part of this page isn't going to show that. There's some land where we're passing over. Where's that? Oh, that's the southern tip of South America being passed over there. And some islands off to the side. So that's the land that the space station is currently over. If you were in the space station right now and could look straight down at the Earth, that's the area you'd be seeing, but it wouldn't be that well lit, and you probably couldn't see through the ocean anywhere near that well, and also there would probably be clouds in your way. Exactly where or to what degrees, I'm not really sure, but my point is that the camera view that we were looking at, and there you can see we're back with the camera view, is not looking straight down, and so you can see now the darkness is finally creeping up from the bottom, and it looks like it's also coming in sort of from the right. Which means, no, the sun won't be in the center of the screen. It will be off to the left somewhat, and I don't know quite how far. It might be completely off the left-hand side of the screen. Right now, the sun would still be off the top of the screen. I'm not sure by how much, but by some distance, I would think. And as we continue as the International Space Station continues to move away from that horizon you're seeing, and of course, as it moves away from the horizon, the position of the horizon changes accordingly. The distance of the horizon doesn't change because that's based on the altitude. But as we move away from that lit horizon and more over the night side of the Earth, you'll see more and more dark area underneath. Again, if we were looking straight down, it would already be nighttime directly below the space station, but we're not looking directly below the space station. The International Space Station orbits the Earth about once every 92 minutes, for those who don't know that. And so most of the movement that you see of the Earth below isn't actually the Earth rotating relative to, say, for example, the sun, but it's rather the Earth rotating relative to the space station, which is really not the Earth rotating at all. It's the space station moving around the Earth. It's in orbit, falling with style, as Buzz Lightyear put it. It never quite falls to the ground because there's curvature, and as it's falling, it's also uh, moving in a direction that in a straight line would take it farther from the ground. So it's the combination of the falling toward the ground and the flying in a straight line that would take it away from the ground, which as those two are combined, gives it just enough curvature in its path to stay at approximately the same height. And the other page, if we scroll down here, you can see it's showing 260 miles altitude. Now, I don't know if that's a current altitude reading, or if it just says that all the time. But if you look it up online, it'll say, I think, 254 miles altitude, which I think is the average. And we're getting quite a bit of glare on the screen now. You can still see the horizon, of course, because it's very well lit, so it shows up through all that glare. And parts of the space station itself are also quite well lit in this image. Now, if you look at the cylinders, you can see what direction the light's coming from. The solar panels appear to be appear to be lit from the wrong side, and I'm not sure exactly why that is. Well, it's, there's light bouncing around from one part of the station to the other. There's glare from what direction light's hitting things in. There's all kinds of stuff going on. But the cylinders, it's easy to tell what direction the sun is actually in. As a matter of fact, the cylinder over on the far right, again, I'll point at it with my mouse. I don't know if you can see that. On the far right, you can see there's an upper portion there that's pretty much ball shaped. And although there's a shadow from the part above that, you can see the sun is off to the left hand side, and not really so much up or down from there. Which, well, now that just went into the dark, and so you can't see that anymore. So evidently, the sun has gotten behind the horizon with respect to that part of the space station. Now, there's still going to be some light shining on it. The problem, I think, is that the light that's shining on it isn't shining on a side that we can see from this camera angle, or at least not enough of it. And part of that has to do with how well the camera adjusts itself to the dimmer lighting. Each camera, of course, is going to be a little different in that respect, and I don't know how much bearing that has on the experiment that they're doing. But that's it's an experiment. They're trying these cameras out. They're testing them to see how durable they are out there in space, how well they can handle this kind of the kind of direct radiation that they're getting from the sun out there, and the various lighting conditions and the extremes of heat and cold, and it's all about learning. So now, as you can see, the remaining lit part of the horizon is just kind of a sliver, and it's getting less and less of it. The middle of the screen now is no longer lit, and little by little, it's just going off the left-hand side. Now, if we go back and look at this other page again, you can see that the crosshairs have went into the blue area. That's the area where at the altitude. Oh yes, and I just noticed it says altitude 258 miles now. So apparently that is updating in real time. Um, and at now I'm guessing that's 258 miles above whatever's directly below it. I don't know. Maybe that, I'm not sure if it's testing, reflecting something off a surface, or if it's doing a calculation based on sea level or what. So I'm not sure exactly how it does that, but it does change apparently. At any rate, so that's why the space station itself is no longer lit, because at the altitude that it's at, the sun went behind the horizon, and as you can see, the horizon itself has very little light left shining on it. Now, of course, the sun being below the horizon, it's still lighting up the atmosphere down there below the horizon, and some of that light does reflect through the atmosphere and come around. As a matter of fact, at night, part of the reason why the sky is usually sort of a dark blue at night is because of blue light that's bouncing around in the atmosphere from the daylit side, and manages to make it all the way around to the night side. Uh, because the moon really doesn't give off very much light. It's a tiny percentage of the amount of light that the sun gives off. The moon's light, of course, is all reflected sunlight, and and most of the light reflected off the moon doesn't make it to the Earth. It goes in other directions. So that's it for the sunset. And as you can see back on the map here, we're well into the night. So it won't be terribly long before it'll go back into the daylight. But I'm going to go ahead and end this video and call it good enough. Thank you very much.